Warahmatullahi wabarakatuh. I'm Riggita Putri from Intitut Teknologi Bandung. I will explain my research entitled Analysis of Vortex Development over Eastern Indian Ocean using Potential Vorticity. Indonesian geographic location causes the region to have many phenomena. A phenomenon that is quite significant influence on wind frequency in Indonesia is a vortex event. The vortex can also cause weather disturbance or even develop into cyclones. One of the low-level vortex phenomena that is often studied in Indonesia is the Borneo vortex. Meanwhile, there is a low-level vortex whose occurrence frequency is quite significant compared to other areas in the Indonesian maritime continent, namely the vortex over Eastern Indian Ocean. This vortex suspect as one of contributing factors of flooding event at Jakarta and plays a role in the development of tropical cyclone in the Indian Ocean. Hence, both formation and development of this vortex is very important to study. Low-level vortex formation is associated with a blocking biotopographical feature and effect of vorticity anomalies in the upper troposphere that move toward the surface. Analysis of formation mechanisms that and characteristics of this vortex can be explained by potential vorticity. Analysis of potential vorticity is quite widely practiced at present to study atmospheric phenomena such as the diagnosis of cyclone development and movement. Therefore, further analysis will be made regarding the characteristics of the emergence of vortices over Eastern Indian Ocean, as well as analysis of the evolution and strengthening of this vortice through potential vorticity parameter based on the characteristics obtained. The data used in this study is ICMWF era interim and reanalysis data for 18 GGF period data. Zonal wind and meridional wind data were used for vortex identification. Meanwhile, zonal wind, meridional wind, and temperature data were used to calculate the potential vorticity. Surface temperature were also used for further analysis. A vortex is identified following a study by Chang et al. The vortex identification study area with coordinates that shown on figure. After determining the vortex using streamline, the relative vortex value will also be analyzed on this date when the vortex was identified in the previous method to increase objectivity in the identification of phenomenon. Calculation of potential vorticity refers to the following equation, where PV is the potential vorticity of isentropic coordinate. The potential vorticity were calculated at the isentropic level, while the data used are pressure level data, so that each component must be interpolated in the isentropic level first. The interpolation method used is linear interpolation. Based on Hoskin, the concept of potential vorticity anomalies can connecting upper level and lower level. Our upper level in the tropic is the same as the middle troposphere. It's about 500 hectopascal. Lower level is where the phenomena was identified is in 925 hectopascal. The frequency of occurrence in each year was different. The vortex identification process resulted in a total of 84 vortex system occurrence in 295 days during the period of analysis. The average lifespan of the vortex system that occurs ranges from 1 until 11 days, with 3 patterns of vortex direction of motion: stationary, moving west, and moving east. Vortices with a fixed direction tend to have a relative shorter lifespan than the vortices that have a west and east direction of motion. This figure shows the spatial distribution of 84 vortex systems over Eastern Indian Ocean. After obtaining the characteristics of the vortex movement, then it will be analyzed through composite potential vorticity analysis of vortex evolution. Analysis of composite potential vorticity anomalies will be carried out to see the beginning of the formation of the cyclonic pattern of this vortex system. In the composite of potential vorticity anomalies, it was seen that a few days before the event, there was strong negative anomaly from west and south. 3 days before the event, the negative anomalies from the west began move eastward. Negative anomaly of potential vorticity got stronger and formed a cyclonic pattern that began to appear on the second day before the event. This suggests that there is a negative potential vorticity anomalous affection from the west of the vortex system. Negative vorticity anomalies from the west remains connected to the vortex system and amplifies the formation of its cyclonic pattern. The existence of a negative advection of potential vorticity anomalies from the west, which is getting stronger. It also strengthens the cyclonic pattern, which is further identification as the vortex. On the following days, it was seen that the center of the vortex was moving westward about 200 km from 0 point. The evolution of the vortex moves eastward has the same mechanism as the vortex moves westward. On the day of the event, maximum negative potential vorticity anomalies with a full cyclonic pattern has appeared in a center of the domain about 0 km distance. The wind pattern also shows a cyclonic pattern. On the second day of formation, shown in this figure, the vortex center moved eastward. Then evolution of stationary vortex is also same on other vortex. On the second day of formation of the vortex, which is shown in this figure, the center of the vortex doesn't change, which indicates that the vortex is stationary. Potential vorticity anomalies can form either at the upper or lower level or vice versa. Negative potential vorticity anomalies at the lower level tend to be stronger than the upper level, so that the anomaly at the lower level is likely to affect the anomaly at the upper level. This shows that the event of vortex over Eastern Indian Ocean originated from the affection of potential negative anomalies from the west. The cyclonic pattern that was formed was not due to the influence of the negative anomaly from upper level potential vorticity. Based on the identification result of the vortex phenomena, the stationary vortex tend to have relatively short lifespan. The negative anomaly values of stationary vortex tend to be weaker, and on the second day and third day of vortex event, the vortex system is no longer connected with negative potential vorticity from the west. Then the vertical plot shows that on the 3 day vortex occurrence in the system that moving eastward and westward is getting stronger due to the strengthening of the negative potential vorticity from the west, which causes the vortex system lifespan to be longer than the stationary vortex. To analyze the movement of vortex, it can be seen that the vortex system tends to follow positive SSD anomalies. The evolution of the vortex movement of the first day, second day, and third day of the vortex shows that the vortex tend to move toward positive SSD anomalies. In the previous research suspect that the vortex is triggered for flooding in Jakarta. Take a look at the analysis based on potential vorticity. The negative anomaly starts to strengthen until it forms a cyclonic pattern on 31st January. The cyclone pattern associated with the negative anomaly reach the maximum anomaly value or the most negative potential vorticity on 1st February. But the negative potential vorticity anomaly in the vortex system are not directly related to potential negative vorticity anomalies in southern part of Sumatra and Jakarta. Based on the analysis of potential vorticity source in this figure, the atmospheric instability in the Jakarta area that triggers flood event is related to an increase in meridional wind from north due to the vortex system in the Eastern Indian Ocean. Based on the identification, the vortex event, it was found that vortices in Eastern Indian Ocean tend to move. There are 3 characteristics of vortex, namely vortex